The Engineering Spot presents Why are units important in science and engineering, and what are some of these units? Sometimes qualitative observations are made, and in the case of a new high-rise complex, a businessman walks by and says to an engineer who happened to work on this project, "That middle building is tall." And the engineer replies, "Yes, it sure is." That's typical engineers. It just takes one to know one. It's not a very useful response. Units, however, provide greater accuracy and detail. So let's again take the case of the businessman remarking, "That middle building is tall." The engineer replies, "Yes, it stands 480 feet tall." That's a more quantitative response, and in many applications, it's a much more useful response. Which leads us into the question, why are units important in science and engineering? Well, suppose there are two scientists in a lab. This is not the beginning of a joke, by the way. One scientist asks the other, "How much sulfuric acid should I add?" And the other scientist replies, "Enough and no more than that." So the other scientist could end up pouring in too much or too little for the experiment. So let's take again the same scenario with two scientists in a lab. And the first scientist asks the other, "How much sulfuric acid should I add?" The other scientist replies, "We need to add 20 milliliters." Now let's examine a team building a concept vehicle. These have a lot of tight tolerances and specifications to them, even as a concept. And the mechanic asks the engineer, "How tight do you want the lug nuts?" And the engineer replies, "Tight, really tight." This is not very helpful, considering if it's too tight, the lug bolts could be destroyed or at least weakened. The rotors could be warped, or if those are alloy rims, they could be damaged. So again, let's take the example of a mechanic asking, "How tight do you want the lug nuts?" And the engineer replies, "The design calls for 100 pound-feet of torque." That is a more useful response. So units provide a standardized method to express a quantity. From these examples, and from many more applications, this is very important for scientists and engineers. Units are used to express such quantities as length. They're used to express mass, and they can be used to express time. Although the time does transcend the different measurement systems. Units can also express angle or temperature. Units can be combined to express other units. Say, for example, a ball is dropped off the top of a tall building and it's going to pick up speed, much in the same way that from a red light, when the light turns green, or from a stop sign, a vehicle will come up to speed through acceleration. Units again can be combined to express other units, such as weight. We can also combine units to express, in this case, we have a crate and a man pushing on it, and this is force. That arrow with the F represents force, and of course, yeah, since it says fragile and not fragile, it's probably some stupid lamp in there. Units can be combined to also express rates, such as speed. Oh, by the way, this was just for aesthetic purposes only. And that's a lot of mileage on a vehicle, by the way. So really, don't drive that fast. And something like pulse rate can also be used in combining units to express a rate. And that would be something you might see with a wearable device. Units can be multiplied or combined to express other units, such as multiplying a unit by itself a few times to express volume. Or in this case here, we have a 5 kilogram mass on top of a desk on a floor that's exerting pressure the same way there's pressure being exerted on a tire. And that's a combination of different units. So what are some common units? Well, let's examine a few of these. Some common units include length. In the metric system, we use the meter, the kilometer, the centimeter, the millimeter, the micrometer, and this is getting really small, that little goatee on the U means the Greek letter mu, and then we have the nanometer. And for the imperial system, there's the foot, the mile, the yard, and the inch. For mass in the metric system, we use the gram, the kilogram, and the milligram. In the imperial system, we use a slug. For time, in both of these measurement systems, we use the second, the minute, and the hour. Some more common units include using volume, and for the metric system, that would be the liter, the milliliter, the cubic meter, and the cubic centimeter. In the imperial system, there's the ounce, the pint, the quart, the gallon, the cubic foot, and the cubic inch. To express area in the metric system, we use the square meter and the square centimeter. This, by the way, is not a canonical list of all units. This is just hitting the high spots on these. In the imperial system, we have the square foot and the square mile. For speed, in the metric system, we use kilometers per hour as well as meters per second. In the imperial system, we have miles per hour and feet per second. We have some more common units. There are a lot of them, by the way. In the metric system for acceleration, we use meters per squared second and kilometers per square second. In the imperial system, we use feet per squared second, and we use miles per hour per second. That, by the way, is very helpful with the examination of acceleration and deceleration of a vehicle. For weight in the metric system, we have the newton. In the imperial system, we have the pound, the ounce, and the ton. For force, we have the newton in the metric system and the pound force in the imperial system. And that brings us into torque. We have the newton meter, and then we have the pound foot. There are some more common units, and we're getting towards the end here, folks. We have for energy, the joule and the kilojoule in the metric system, and we have the calorie and the kilocalorie in the imperial system. For power, in the metric system, we use the watt, the milliwatt, the kilowatt, the megawatt, and the gigawatt. In the imperial system, we have the horsepower. For angle, for both of these measurement systems, we have both degrees and radians. For temperature, getting back to the metric system, this is based off of water. We use degrees Celsius, and then we also have Kelvin. And then there's degrees Fahrenheit in Rankine for the imperial system. Some more common units include frequency. It was originally in cycles per second, but a more recent change has been hertz, kilohertz, megahertz, and gigahertz. And finally, pressure is measured in the pascal in the metric system, as well as the megapascal and the gigapascal. And in the imperial system, it's measured as pounds per square inch. These are just a few of the many units that are used. There are many more units, and they're used for their appropriate purposes and uses. So make sure that when you have to report a value, you use the proper units. Thank you for watching. Please be sure to sign up for more great videos.